Diverging plate boundaries. So crust is created at divergent plate boundaries. The main types, you're talking mid-ocean ridges and rift valleys. So where is the divergence? We know there's divergence at all of these orange boundaries. They're all moving away from each other. That's a pretty cool spot. Iceland, we're probably going to get to that very shortly. So, mid-ocean ridges, basically the rock coming out of them is basalt, and these are some nice pillow basalts. See, they look kind of like these rounded sort of shapes. At mid-ocean ridges we can see we have this sort of formation of basalts, because they kind of a little bit runny when they come out, and then they form these sort of round shapes as they blob their way out. I guess that can you can probably visualize that pretty well. So here's some more pillow basalts. They're on land, little camera lens there, so we can see the big globules. Pretty cool. But these will only form when the basalt's coming out underwater. So this is Iceland. It is rifting. So this is actually a plate boundary. It's a divergent plate boundary, and it runs through the middle of Iceland. Eyjafjallajökull glacier erupted a lot of gas in 2010, disrupted a lot of air travel. Because that gas had essentially really fine obsidian, so fine volcanic glass in it. And basically if that gets in an engine of a jet airplane, it will solidify in there, and then it's not going to last long, is it? It's going to come straight to the ground, have a bit of a crash. Unfortunately, you don't have access to this one. This is one of mine, but you can look up the BBC Volcano Live episodes are on YouTube. You can have a look at those, particularly ones about Iceland. The way that I've done this video is different though. I've basically found all the Iceland stuff out of all of those episodes, but feel free to watch them. They're pretty good. So Iceland is on the mid-Atlantic ridge. So it's diverging here, pulling away from each other. It's also sitting on a hotspot. So a hotspot is when there's a plume of magma punching up through the crust that's coming usually from the mantle. And that plume eventually forms a volcano and it erupts on the ocean floor, building up a mountain. A better example of that is Hawaii, but we'll have a look at that soon. There's a lot of geothermal activity in Iceland because of all this volcanism. And what that means is that all of their electricity actually comes from the geothermal, so it's all renewable. And they also, they've got a lot of hot water, so hot spas, even during the winter time, is pretty cool. So we can see this rifting. It's forming these floodplains, because the weathering and erosion is going to end up in these cracks. And you do get a lot of lakes along when you've got rifting on land, but that's pretty cool. So it's cracking up in a lot of different spots. It's not one neat crack going up the middle. So Lake Malawi is another example of rifting on land. So it's called part of the East African Rift, and so there are a lot of lakes along here. Lake Malawi is pretty cool. That video is in the links, so you can have a look there. Okay, this is where it is. So East Africa, and then we have, so these are all divergent boundaries. So there's a lot of breaking up through here, but this is the rift zone. So all these little bits are where the continent is cracking up, and then we've got lots of volcanoes through there as well. So eventually we'll probably get an island out of this part, out of East Africa, and it'll be split just like up in the Red Sea. There's another split there. So similar to the Red Sea, we're going to get another sea through here. We might just have a look at that video. We can see forming on land, then sort of like get water inundates it, and then eventually we've got a mid-ocean ridge. Let's have a look. Not as exciting as I remember. So transform boundaries. So they're the least common type of plate boundary, and when we looked at the global map, we saw that there's only a couple of main spots where it happens. Think about transform faults. They are very common within plates. So whenever there's a stress within a plate, that stress is often relieved by having a transform fault in the plate. So not common at boundaries as a tectonic plate boundary, but they're common within a plate. Now, what happens at a transform boundary is the plates mostly slide past each other, but edges aren't smooth. So basically they get caught up, build up pressure, and then quickly move, and it results in some pretty serious earthquakes. They're not as powerful as the ones that happen at subduction zones, for instance, but the thing is, they're shallow. So being right at the surface creates a lot of problems for people who are living there. Think of the San Andreas fault in California, but also think of the Christchurch fault in New Zealand along the Alpine Ridge. So they mostly slide past each other. They do get jagged. You can get a little bit of uplift or burial because of this, because the edges are jagged, so it kind of acts as though there's a mini divergence or a mini convergence. So when there's little bits pushing against each other, you'll get a mountain range. So our transform boundary is there, and then there's a little one over there too. So that's San Andreas, that's New Zealand. So San Andreas fault. So there's subduction to the north, there's subduction to the south down here, but then what we have in the middle is we have a transform. And we can see that there's a mid-ocean ridge here with some transform faults that's moved. Now, what is interesting to note is we can't see that same mid-ocean ridge down here. It's not because it didn't exist, because it sure did, but it's now gone. Where has it gone? We've got subduction still continuing down to the south. So the thing about the transform fault here is it does move at, or it should be moving at 3 to 4 centimeters per year, but most years it doesn't move at all. Builds up, builds up, builds up, builds up pressure, because it should be moving, but it's not because it's jagged. Then eventually all that pressure releases in one go. So maybe over 25 years, we're talking a whole meter. If it hasn't gone in 25 years, we know that it's going to be a big one. It's going to move a whole meter. Sometimes it moves significantly more than that. Let's have a bit of a look. So here's North America. Here's the mid-ocean ridge. We can see that it's getting subducted right here. And because it's been subducted, we've got a problem. Subduction, so now no longer are they moving towards each other. Now what we have here is we have other movement resulting in a transform fault. So what we have a lot of earthquakes, and we have a lot of really shallow earthquakes all along here. And like I said, they're not completely smooth, so we do have a mountain range pretty much most of the way along the San Andreas fault, or certainly in particular areas.